Okay, so today we are talking about variables on both sides of the equal sign and talking about the different solutions that you can get. So the type of solutions that you can have are infinite solutions, one solution, or no solution. So when you get infinite solutions, your reasoning is that your left side is always going to equal the right side. So left side equals right side. And the reason why you're going to get infinitely many solutions is because no matter what number you plug in for x, you're always going to get like 1 equals 1, 2 equals 2, 3 equals 3, 4 equals 4. So it doesn't matter what number you plug in because you're going to get the same solution on both sides, which means since we have infinite numbers, you're going to have infinite solutions. Okay, and I can show you guys how this is equal to the other side, because if you do your distributive property, you get negative 2x minus 6 equals, again, negative 2x minus 6. So since you have the same thing on both sides, that means that you are going to have infinite solutions. Okay? When you have one solution, this just means that you have different coefficients. And your constants do not matter. So different coefficients, constants do not matter. Okay, so what I mean by coefficients, these are the numbers that are attached to the variable. So as you guys can see, 3 and 11 are different, so I know right away that I'm just going to get one solution, because if your coefficients are different, you are going to end up with x equals some number, which is what you guys are used to. Okay. And the last thing that we're talking about is no solution. So if you have no solution, this just means that you have same coefficients. So for this example, if I were to combine x plus 2x, that will give me 3x plus 1 equals 5 plus 3x. So notice how I have on both sides. And the reason why it's going to give me no solution is because when I subtract the 3x from both sides, I'm just left with 1 equals 5. So is it possible for 1 to equal 5? Nope. So that's why we call it no solution. Okay. And something that I should put over here too is if you have same coefficients, different constants, then you're going to get no solution because you're going to have something that ends up like this. Okay? So these are just the characteristics to look for infinite solution, one solution, and no solution. Okay? So let's just try some on our own. So remember, when you are solving these, you must always simplify first. So looking at my left side, I notice that I can combine the negative 9 plus 3 to give me negative 6. I can also combine my x and 2x because those are like terms, and that would give me 3x. And then over here on the right side, I see a distributive property that I can do. So 3 times x is 3x, and then 3 times 2 is 6. So I can go ahead and keep solving this, but I know right away what kind of solution I'm going to get because I see same coefficient on both sides and different constants. So same coefficient, different constants is going to give me an answer with no solution. Because if I were to keep solving this, I can subtract 3x over here. My 3x's are going to cancel on both sides, so I'm just going to be left with negative 6 equals 6, which is not true. Okay. All right, number 2. So again, I see distributive property here. So negative 1 times 3 is negative 3. And negative 1 times a negative 6b is a positive 6b. And then over here, I have a positive 6b plus 5. And again, just like the one above, I see same coefficient, different constants. So if I were to solve this, I would be left with negative 3 equals 5, which is not true. So once again, this is no solution. All right, next one. So 36 minus 7p. So if I were to do the same thing over here by doing the distributive property, I can't do anything on the left side. Those are already simplified, so I'm just going to leave that the same. Negative 7 times p is negative 7p, and then negative 7 times a negative 5 is a positive 35. So once again, I see same coefficients because a minus 7 is the same thing as a negative 7 over here. I see same coefficients, different constants. So once again, just like number 1 and number 2, this is also no solution. Okay, number 4. So let's go ahead and solve this one. So first thing I see is I need to simplify the left side by doing the distributive property. So negative 3 times v is negative 3v. Negative 3 times 4 is a negative 12. And then I have 2v minus 37 on the right. Now notice here how I have different coefficients. So different coefficients mean that you are going to get a one solution answer. So you do have to solve this. So you do have to solve this to figure out what answer it is. So again, you're just moving all of your variables to one side. So I'm going to move the 3v over here to the right. I'm left with negative 12 equals 5v minus 37. Next step, I'm going to add 37 to both sides. And this is going to give me a positive 25. And then my last step to get v by itself is to divide by 5 on both sides, and I get v equals 5. So notice here how when I had different coefficients, I came out with one solution, which is what I expected. Okay? All right, and then the last one down here, so I can simplify the left side by doing the distributive property. I'm going to be left with 4k minus 32 equals, the right side is already simplified. And notice this time how I got same coefficient, same constant. So when your left side equals the right side, that means that you're going to have infinitely many solutions. So your answer here is just infinitely many solutions. Okay, so this was just a basic review over what types of solutions that you can get. So it's important that you guys can look at a simplified equation and know whether you're going to get no solution, one solution, or infinitely many solutions. So let me know if you guys have any questions.